All right, let's work on one more problem. We are working with how to deal with the concentrations of weak acids and weak bases. On this particular problem, it says what concentration of nitrous acid is needed to make a solution with a pH of 2.49. Assume that it's a monoprotic acid. Always important whenever we're doing problems is to look at the information that you're given. So we're given a pH of 2.49, and look at what you're being asked for. We're being asked for what's the concentration of nitrous acid. I hope that you're starting to recognize that we need to really think about these things. Is nitrous acid a weak acid or a strong acid? Because the answer to that is going to determine what I do. All right? Is nitrous acid one of the 6 acids you're supposed to recognize? The answer is no. It's not one of the ones, so therefore it's definitely a weak acid. So as we get ready to get going, I'm just going to erase this stuff so that we can move on with the PowerPoint. As we get going, what can I do with the pH? I know that with the pH, I can get the hydrogen ion concentration by taking the inverse log. Now I have the hydrogen ion concentration. We do need to remember that nitrous acid being weak means that the concentration of acid does not equal the concentration of hydrogen ion. Remember, if nitrous acid were a strong acid, then we could say that this answer and the concentration of our acid the same, but it's not. Nitrous acid is weak, and again, very, very important. So we're not done yet. What can we do with this hydrogen ion concentration? We need to plug it into the equilibrium expression. So the first thing you have to do, we write a general formula for the dissociation of weak acids. This is a requirement. You have to write this equation. We're going to set up an ice table. And again, our reaction goes in the top. I don't think I've mentioned that before, but our reaction's up here. Here's our HA. You can consider a little arrow here. Here's our products. Initial concentration, change, and equilibrium. So you can even put the ICE, right? Initial, change, concentration. But, we're not starting up here and working down. We're gonna start right here, right? Here's the H plus concentration that we just calculated as a result of having the pH. And we know that if this is the H plus concentration, that our anion's concentration is the same. Yeah? Okay. Now over here, we don't know what the concentration of the acid is. That's what we're trying to find out. But we know that this is minus, again, the concentration of hydrogen that we calculated. And then backfilling. This would have gone down by that much. These two would have gone up by that much. And here we are at X, and these two are 0. Okay. There you go. Now, we've done this, right? In all of our other calculations, when we were doing it this way, we would say when this was X and that was a number, we'd say, hey, you know what? This X is so small, we're gonna neglect it. And we're gonna let it drop off just to make our math a little bit easier. We're gonna do the same thing this time because that value is so small. So we're gonna let that drop off and it's just gonna be X. Now we will write our equilibrium expression, products over reactants, and now we're gonna fill in our information. So we have, again, using the table, finding our acid. This is nitrous acid. Finding our acid, there's our K value. We're gonna plug that in. We're gonna take our concentration of H plus and our concentration of A minus. They go there, and X goes on the bottom. All right, and now we're just gonna work the math. So now you have 7.2 times 10 to the minus 4. You're gonna take those two values and square them over X. Now we're just going to solve for X. So how do I get X by itself? X right now is in the denominator. It's downstairs. So we're going to multiply this side by X. We're going to multiply this side by X. Now X is here. X times 7.2 equals this. We got to get rid of this guy. And so since this is multiplication, we're going to divide by 7.2 on both sides. There you go. And now we're ready to grab those calculators, do this calculation, and we get the concentration of our acid. We're going to put it in scientific notation. How many significant figures should this answer have? Stop now. And there's your final answer, 1.5 times 10 to the minus 2.